It actually all worked out, even with the round off. It worked out. Somehow I made a mistake in this last calculation, but I just redid it right when you went tonight. When I multiply all those together and take the square root, this is what I get. The exact area of the triangle is 11. And look how close that was, see? And look how easy that is. Isn't that easy? So just because there's a little bit of rush there and whatever, and I was befuddled, let's do another quick one. It's no more in your notes. That's so easy. There's only one example. So let's just make up some random points. Point C, give me a point. Birthday boy.
3.
Well, I need a point.
Oh, 3, 2.
Okay, perfect. Okay, Kendall, give me another point.
4, 5.
All right. And Paige, give me another one.
1, 2.
All right, I'm hoping all this works out okay, because you guys kind of got a little pattern going here. But I think we're good. I think we're gonna be good. All right, so what do we do if we want to find the area of this triangle? We pick a point, and I'm going to be brutally honest with you. It really doesn't matter if you emanate from the same point for area, but it does for other things. So I kind of want you to get in the habit of just picking a point and working from that point, okay? So which point shall we work from?
S.
S. All right, so that means we have to build the coordinates, the directed distance, the vector from S to H. So from S to H. So 1 to 4 and 2 to 5. All right, and then we're going to go from S to C, from 1 to 3, 2, and 2 to 2, 0. That's okay, that's perfectly okay. So once we've done that, then we build a determinant out of those numbers. And what would be the value of that determinant? -6. And then, oops, I erased my points. And then here is the part you have to remember. It's half of that. It's half of that. So the value of this determinant is -6. So the area of the triangle will actually be 3. Okay? Two things, we already talked about them. Depending on how your things will organize, if you would have done SC first, it would have come out positive. So don't worry about the negative sign, just ignore it. And then remember to cut it in half. Area of triangle is always a half. Think about it. Half base times height. Half side, side, side. Hero's formula, half the perimeter. There's always a half when you do a triangle. Okay? All right, perfect. All right, so that's that. Now, next, oops, this way. Now we're going to find what's called the partial fraction decomposition. Now that sounds scary, but it too is very, very easy. Okay, so I want you just to think for a minute. You don't have to write this down, I just want you to think for a minute. If I ask you to add 1 over x plus 2 and 2 over x minus 5, if I said let's add those together, these little fractions, what would you have to do to make that happen? You'd have to have a common denominator. So you, again, don't write this down, just watch so you can see where we're headed here. Because we're actually going to be doing this in the opposite direction. So if you had to add them together, you would get your common denominator, which would be x plus 2, x minus 5. And then you would take x minus 5 times 1, and x plus 2 times 4, times 2. And you would end up then with 3x minus 1 over x squared minus 3x minus 10. I know I did that quickly, but did you kind of follow what was happening? If you're gonna put those two fractions together, this is what you would end up with. Okay? So now we're gonna start with that, and we're gonna work backwards to the two little fractions that got added together to make that. Okay? What do you think the denominators of those two little fractions will be? The denominators. Well, where did this denominator come from? It came from multiplying these two together. And where did those two come from? Weren't those the denominators in the original problem? So how about I factor that? X minus 5, x plus 3. So my denominators are x minus 5 and x plus 3. The order doesn't matter. Put one of them in the first fraction and one of them in the second fraction. You okay with that? Now, I have no idea what's going to go on top, so I'm just going to call it A and B. Now, what if, I'm going to move that over a little bit, it's kind of behind the screen. So, what if I said to you, take this equation right here that you just built, that big equation, and get rid of the denominators. In other words, clear the fractions. What would you do if I said, let's get rid of the fractions, clear the fractions? What would you do? Multiply by these two things. So I'm going to multiply everything by x minus 5 and x plus 3. I'm going to get rid of the denominators. So x minus 5, x plus 3, x minus 5, x plus 3. Because what will happen is, that is completely gone, and leaves me with just my numerator. This part will go away, and leave me with this. This will go away, and leave me with this. Now take a look at that and make sure that that is making sense to you. You've done that before. Not with letters like this, but you've done that concept before. Okay? Now let's distribute all that. So we have ax plus 3a and bx minus 5b. There's a lot of variables in that problem. Now it's an equation. Does it make sense to you that however many x's you have on the left side will be the same as the x's you have on the right side? So in other words, this has to equal this plus this. There, it's an equation. So they ultimately have to be the same on both sides. So whatever A and B are, they would need to add up to give you 5. Does that make sense? So 5 equals A plus B. Now similarly, here's a -1 right here. Don't these have to combine to give you -1? Because those are the not x parts. So -1 has to equal 3A minus 5B. What do I do with that? Substitute, or eliminate, or Kramer's rule, whatever flips your switch, folks. Somehow you gotta figure out what A and B are. So what do you wanna do? I'll do anything you want. You want it? Oh, I'm hearing different things. I can only do one. Let's vote. Who wants to substitute? Who wants to eliminate? Oh, none of you people. Oh, okay, that's all right. That's all right. Do whatever you want. How many Kramer's rule? All right, substitution wins. So here we go. If we're gonna substitute, at your seat you can do your own thing, right? Do your own thing. I'm gonna substitute. So I guess I'll say B equals 5 minus A. And I'll put that in right here. So -1 equals 3A minus 5 times 5 minus A. Hopefully you're getting the same thing I am. I got A equal 3. And if A equals 3, then B has to equal 2 because they gotta add up to 5.
I have a really dismissal of one.
Of course you do.
Get a load of this guy.
It's not one yet, but when it's one, you can go. I believe you. Okay. So, anybody else get A equals 3? Okay. So, my answer is not this. Don't stop here. What was your job? Your job was to find the partial fractions. These are the partial fractions. So my answer is 3 over x minus 5 plus 2 over x plus 3. Those are the partial fractions. If you added these together, that is what you're going to get. This is a very big calculus deal, folks, because it is harder. We have something called integration, and it's harder to find the integral for something like that than it is to find integrals for these easier fractions. So we like to break things apart in calculus class, and this is how you can break apart a big rational expression. All right, so we're going to do another one here in a second. Let's review those steps real quick. What was the very first thing I had to do? I had to factor my denominator because those factors are what's going to give me my partial fractions, right? Then what did I do? Then I cleared the fractions by multiplying through by the denominator, and that left me with an equation that looked like this. And then I wrote a new equation from just the x parts. That's the red. And then I wrote another equation from the number parts, the non-x parts, that's the blue. And then however you want, you're going to solve that little system and come up with your answer. Now, again, the order you put these doesn't matter. If you had A over x plus 3 and B over x minus 5, that's okay. This is still going to ultimately be your answer. Your A and B will be switched, but it won't matter because you had them switched over the denominators. Okay? All right. Oh my goodness gracious. Oh my. Okay, what am I gonna do? This looks terrible. Okay, we're gonna break this apart into its partial fractions. Step one, factor the denominator. Don't ever worry about the numerator. You're gonna factor the denominator. So how does that guy factor? Take out an x. X minus 2, x minus 2. All right, now be careful. Remember, you are adding together things that ultimately will give you this answer. So my denominators are going to be an x minus 2, and an x minus 2 squared. Now I want you to think about that for a second. What would be the common denominator of these three fractions? Wouldn't this be the common denominator of those three fractions? So when you have a squared factor, a repeat factor, one that happens twice, you have to put it in alone and then double or square. If all the factors had been different, then you would just have all three different ones. But when you have a square, you have to put it in alone and as a square. Okay? So then my numerators, all right, here we go. What do we do next? Who remembers?
Clear the denominators.
We multiply to get rid of the denominator. So I'm gonna multiply everything by this. This is my denominator. So over here, when I multiply this guy by this, doesn't it all just cancel out? And leaves me with negative x squared plus 2x plus 4. That's all that's left. Now remember, I am multiplying this by x and x minus 2 squared. So the x's are going to cancel, but I'm going to have a times x minus 2 squared. That's what's left here. I'm multiplying by x times x minus 2 squared. Okay, what's going to happen there? What's going to cancel? One of the x minus 2's is going to cancel. So I'll have bx, x minus 2. Multiplying by x and x minus 2 squared, what's going to happen here? Just cx. All right, what do you think I have to do now? I think I have to multiply this stuff out. So I'm going to have a times, what's x minus 2 squared? 4. It's got a 4 in it.
X squared minus 4x plus 4.
Perfect. I don't know who said that, but whoever said it was right on target. And this is going to be b times x squared minus 2x. And then plus cx. All right, let's distribute. So I have ax squared minus 4ax plus 4a. Please don't let all these letters confuse you. I know there are a zillion letters in here. There are a lot. Don't let it confuse you. Now, remember, this is an equation. So this equals this. So if these things are equal, don't all of the x squareds on each side have to match? So doesn't -1 have to equal a plus b? Now just think about that. It isn't complicated. It's like logical. This is an equation. So then you have -1 x squareds over here, and you have a and b x squareds over here. They have to be the same. All right. Now, what about our plane x's? Well, I've got 2 of them on this side. How many plane x's on the other side? There's 1, there's 1, and there's 1. Is that right? So 2 has to equal -4a, -2b, and c. Scary, but do not be afraid. And then here's this 4. This 4 doesn't have an x. So it has to match up with whatever doesn't have an x on the other side. So the only thing I see is right here. Would you agree with me? So 4 has to equal 4a. Well, what does that tell me? A is 1. So now I know a is 1. Well, let's pop back up here for a minute. If a is 1, then b has to be -2. Would everybody agree with that? And now here in the middle, let's see, a is 1, so 2 equals -4 plus 4 plus c. I think c is 2. Double check my arithmetic. Is that good? So then I'm ready to write my answer. I gotta use the framework that I started with. A goes over the x, so what was a? 1. So 1 over x. B goes over x minus 2. And c goes over x minus 2 squared. Now, that's a lot. I erased part of it already. That's a lot to keep track of, but it isn't too hard. Does anybody have a question about one of the steps that I did, something that I did that's a real mess there? The big thing I want you to remember is that if you have a squared factor, when you factor your denominator in the original problem, if you have a squared, you have to put in, let's say it's x plus 5 squared. You have to put in x plus 5 as one of your fractions and x plus 5 squared as another one. Okay? All right, perfect. All right, we learned a couple of new things today, so now we're going to do, our last problem is going to be a review problem. So look at the next thing there. And we have already done these. They're kind of important, so we're doing them again. Who remembers anything about this? Note the directions, label asymptotes, holes, and intercepts. Anybody twitching yet? Remember doing this a long, long time ago? What do you do first?
Factor them out.
Yep. And these are easy to factor. They're the difference of squares, okay? Is that all you got?
There's a hole, there's holes at 3 and -3.
Okay, there's something at 3 and negative
And let me guess,
3,
it's not.
but they're not holes. Because where do holes come from? When you cancel. So this problem isn't gonna have any holes because nothing cancels. However, the 3 and -3 are hugely important. Anybody remember what they are? They are vertical asymptotes. Very, very good. So we have vertical asymptotes at 3 and -3. So if you have forgotten, you need to remember that you have vertical asymptotes wherever your denominator is 0. Your denominator would be 0 if you let x be 3. It would be 0 if you let x be -3. Vertical asymptotes, denominator 0. Gotta remember it. All right, who remembers something else? Good, Nate, good. Who remembers anything else? Van?
Isn't 1 the horizontal axis?
Absolutely, and how did you do that, Van?
It's like in the original equation, the first two, yeah.
Exactly. So, Van isn't sure about the words to describe it, but he knows exactly what to do. I look at the highest power of the variable, which is x squared, and I've got 1x squared over 1x squared, that's my horizontal asymptote. Perfect. Who remembers anything else? There are no holes, we've already discussed that. Well, y-intercept? How do we get a y-intercept? We let x be 0. And if you let x be 0, isn't your y-intercept gonna be 0 4/9? Rupees, no matter what you're graphing, anything you graph, if you want the y-intercept, you're gonna let x be 0. That's how you do it. Now, the x-intercepts are what makes y 0. What could you put in here that would make this fraction equal 0? 2? Wouldn't 2 make it 0? And -2. If you are confused at all, make a little note and memorize that your zeros, your x-intercepts, come from the numerator. Your x-intercepts come from the numerator. Time to connect the dots. What do you think's happening right in here? There's definitely a little parabola shape in here. Beautiful. Now we'll see who's thinking and who's still at lunch. What about the rest of the picture? I see some of you going like this, and you're exactly right. Remember this shape, guys? These little hyperbolic deals that look like that? Remember those? You can't cross the x-axis except here, so you can't have anything down here or down here. They're up there. Perfect, good Lord. Next time I see you, which Lord only knows when that is, but I'll see you sometime. Have a happy Easter. We gotta do some more of these, and then we have to do some word problems. So we're looking at a test.